Hi everyone. In this short video, we are going to touch upon. We are going to use basic trigonometry. I've already made a video for basic trigonometry where Pythagoras rule and trigonometric ratios are discussed. In this question in particular, we will be using the Pythagoras rule. The Pythagoras rule states like this: the sum of two smaller squares is equal to a bigger square, or the biggest square. In fact, Pythagoras rule has a limitation. It can only be applied in a right angle triangle. The two smaller squares that we have mentioned are the ones which are connected to the 90-degree, and the biggest square is a side which is biggest square is the square of the side which is opposite to 90-degree, and this is the biggest length always because there is no other angle that you can make 90 degrees or more. Hence, C is the biggest length. Also, the area of trapezium is half times height times sum of parallel sides. This A and B are the parallel sides. Usually the smaller parallel side is represented by A and the bigger one by B. And the height of the trapezium, it's very important to note that the height of the trapezium is simply the perpendicular distance between the two parallel lengths. Trapezium is a quadrilateral, four-sided figure made with straight lines, but it has a minimum number of conditions on it. It just requires, apart from being a quadrilateral, it just requires one pair of parallel lines. That's it. Moving on to this question, we have this figure shows the cross section of a gutter. It consists of a rectangular center, you can see here, with two congruent triangles at it. These two are congruent triangles. Usually we study congruency and similarity uh, in relation to each other, but just for your information, congruent figures are exactly the same. Their corresponding lengths and corresponding angles are equal. Whereas similar figures, their angles are the same, but the size is different. Change in size of lengths only. We can discuss congruency and similarity in much more detail, but right now we're going to focus on this question. These are congruent triangles. If we work for one of these triangles, let's say this is ABC, let's call it B and E, and we call this as F, just for reference communication. The triangle ABD and triangle CFE are exactly the same. Having said that, the first part says how long is AB? AB is this length that we want to find. For the triangle ABE, what information do we have? Sorry, ABT. The information that we have is this length is B, this is 90 degrees, this is 90 degrees, and this is H. How do you find AB? By using the Pythagoras rule. The scenario for using the Pythagoras rule is if you are given two sides and you have to work the third side, or only the three sides of the triangle, right angle triangle are involved, then Pythagoras rule is available. So AB, we have to use the same notation for the length. We are not going to use X or Y. You may use, but I'm going to use AB as it is. That's the more authentic communication. So the length AB is by the Pythagoras rule, AB squared. The two smaller lengths are AB squared and then BD squared, and that should be equal to the hypotenuse AD squared. The two smaller lengths are connected to the 90 degree. AB is to be found. We'll keep it here. AD square remains on the same side, and I'm going to shift BD on the other side. So it's BD squared subtracted from the left hand side. AD is H, so it's H squared. BD is B, so it's B squared, and we have AB squared on the other side. Since we want to find AB only, we don't require the square. How do you get rid of that square? Just by taking square root. Square root means half of the power. So if it is power 1, half of, so if it is power 2, half of this power 2 will be power 1. AB is square root of H squared minus B squared. And that answers our part A here. For part B, Now that we know this length, how long is A to C? A to C, you can see these are congruent. Whatever is AB, same as FC. So AB and FC are same. And this length, if this is A, this is also A. Basically, for part B, we are adding two of these lengths, 2 times h square minus b square, and plus this A in the middle, and that's the length AC. The norm is you write the unknown or the required length on the left hand side. So I'm going to write it here and say this is AC is equal to whatever that is. Then it says find the formula for the area of the figure A in terms of AB and H. Now look at the area of trapezium. We have a smaller side and a longer side and the perpendicular distance between them. Our smaller side is A. So for area, this is 1 over 2. Height, what's the height here? The height is the perpendicular distance between the two parallel sides. So D is the height times the sum of parallel sides. Now look at the smaller side. The smaller side is A, while the longer side is the length AC, which we calculated in part B. The length A to C is all that. A plus 2 times H squared minus B squared. When you combine them, you get B over 2, then 2A plus 2 times H squared minus B squared. You may want to simplify that. It's usually the expectation of the question maker that you present your answer in the most simplest form. I see that 2 is common in both terms in the bracket, so I can take that out and write it like this: A plus square root of H squared minus B squared. And this cancels out. Our final answer for the area of this figure is B bracket A plus root of H squared minus B squared. And that's it. So more of algebra, just very basic information of the trigonometry, the Pythagoras rule, and the area of trapezium. More of algebraic manipulation. Thank you for watching.